back to our channel. The paper we are solving today is IGCSE Chemistry, October-November 2023, and this is the paper number 21. Alright, now let's start with the first question. A gas is placed in a sealed container. The gas has a pressure of 1 atmosphere and this much temperature. Now, the volume they are keeping constant because it's a sealed container, but now they're increasing the temperature. We know that temperature is directly proportional to pressure. So, which row describes the cause of the pressure of the gas and the effect of increasing the temperature of gas? So, cause of the gas pressure. See, there are two types of collision. One is within the molecules, between the molecules, and one is between the container and the particles. So, that is the one which creates pressure. So, A and B are out of the options. Collisions between the particles and the container creates pressure. So, we have to decide between option C and D. Now, since temperature has increased, so the average kinetic energy of the particles must have increased, right? Means the speed increased. So answer is D. Now, question number 2. 4 experiments, each containing a different acidic gas. The dividing glass plates are removed at the same time. In which set of apparatus does the litmus turn red? So they're just giving you a setup that litmus they have placed here in all the 4 setups. Then they're just using different type of acidic gas and they're asking you which one will go up first and convert this into red litmus paper. So we know that the one with less relative molecular mass will move or diffuse faster, right? The gas with less molecular mass, since it is less heavy, it will be able to move faster. Now, carbon dioxide is used here. The mass of carbon dioxide is 12 plus 16 times 2, which is 46. The mass of HCl is 1 plus 35.5, which is nearly 36.5. The mass of NO2 is 14 plus 32. Oxygen is 16 times 2, 32. So this is again 46. And this is 32, this is 12. This should be 44. And SO2 again, sulfur's mass is 32, two oxygens are 32, this is 64. Now you can clearly tell me which one has the lowest mass. It is HCl. So answer should be B. Now question number 3. Group 1 element forms potassium. Potassium forms an ionic bond with group 7 elements. We know that group 1 elements are metals, they form positive charge, and since the valency is 1, it should be K positive only. So option A and B we have to figure out. C is wrong, D is wrong. Metals are not negative charge. Now halogens, we know that they form negative charge. So option should be B. K positive, F negative. Question number 4. X and Y are atoms. X and Y have same number of electron shells, same number of outer shells, and they have different mass number. So this is indirectly telling you the definition of isotopes. So they are isotopes. This is correct. Since they have same number of outer shells, so total number of outer electrons must be same as when outer electrons are also same. So total number of electrons must be same as well. Alright. Then X and Y have the same chemical properties. Since the electronic structure is same, the chemical properties will be same as well. So answer should be A. Lithium chloride is an ionic compound and silicon oxide is a covalent compound. Which statement about both compounds is correct? They are not soluble in water. Lithium chloride is soluble, silicon oxide is not. They conduct electricity when melted? No. They do not conduct electricity in solid form. See, lithium chloride conducts electricity in molten form, but in solid it does not. Same way, silicon oxide does not conduct electricity. So answer correct should be C. They have low melting points? No. They have higher melting points. So the answer should be C. Now, which equations are balanced? So we just need to do the little bit maths here. 2 iron atoms, 3 oxygen atoms, 3 oxygen atoms here. So here we should have 6. So this equation looks balanced. The second equation, zinc carbonate, 2HCl. See, here you have 2 hydrogen atoms, here you have 4 hydrogen atoms, unbalanced. And here you have 2 sodium atoms and you have 1 sodium atom here, unbalanced. So we clearly know that the answer should be 1 and 4. Calcium 1, 2 hydrogen, sulfur 1, sulfur 1, and the oxygen are balanced as well. You can check. So answer should be B. Now, which row shows the formula of sodium carbonate, zinc nitrate, ammonium sulfate? This should be simple for all of you. I'll also show you the working. Sodium has a valency of 1. Carbonate ion is CO3 2 negative, right? So the charge is 2. So you cross multiply this, it becomes Na2CO3. Zinc nitrate. We know that zinc is 2 plus. Unless they mention it, you have to take it the general one, which is Zn2 plus. Nitrate ion is negative 1, right? So when you do the cross multiply, Zn is 2, NO3 is 1. This becomes Zn NO3 whole twice 2. So Na2CO3, ZnNO3 whole twice 2. From this only, you can tell that the answer is B. But I'll also show you the working for ammonium sulfate. Ammonium ion is NH4 plus 1, sulfate ion is SO4 2 negative. Now you can clearly tell me that it will be 2 times ammonium for 1 sulfate, right? So NH4 2 SO4, alright? Now, which statement about hydrogen and oxygen are correct? They are used as a fuel cell. There are a lot of cars out there as well who run on hydrogen fuel cell. So it should be out of C and D. Now, hydrogen and oxygen can be made by electrolysis of dilute sodium chloride. Is this correct? Yes, it is correct. When you do electrolysis of dilute NaCl, you have H plus ion, Na plus ion, Cl negative ion, OH negative ion. Since it's a dilute solution, we know that at anode, this equation forms. I'm sure all of you are aware about this equation. So oxygen is obtained using this. And at cathode, we have the rule, the less reactive ion gets discharged, which is 2H plus. So 2H plus 2 electrons giving hydrogen. So answer should be D. Now, graphite has a giant covalent structure. Which statement about graphite is correct? Carbon atoms form 4 covalent bonds. They form 3 covalent bonds. One valency is free. There are delocalized electrons between layers of carbon atoms. This is true. Graphite is used as a lubricant. True. Graphite is a good conductor of electricity. True. So answer should be C, 2, 3 and 4. Which reaction pathway diagram represents an endothermic reaction? So for endothermic reaction, we should keep this in mind that reactants will have less energy than the product. See, endothermic means you're supplying energy for product to form. So the products will clearly have more energy, right? And the enthalpy change will be positive because you are providing energy to it. You're giving energy, you're increasing their energy. So enthalpy change should be positive. This gets cut. A and D are already cut. All right. Then we discuss that reactant should have less energy than the product. Option B, reactants are on the lower Y and products are on the upper Y. This should be correct. Why C is wrong? It is saying reactants have more energy, products have less, which is incorrect. Question number 11. This will require a little bit of maths. Let me make it simpler for you. So 2 times hydrogen bonded to hydrogen plus oxygen double bonded to oxygen is equals to 2 times HOH. This is the structure of H2O. Alright. Now, in order to solve it using the simplest method, I recommend one way. Just figure out the energy of the reactants, figure out the energy of products separately, and then simply do reactant minus product. If it comes out to be negative, it is exothermic reaction. If it comes out to be positive, it is endothermic reaction. Very simple way, it will avoid any confusion. There are a lot of methods out there to solve these kind of questions, but I find this as the simplest one and my students do as well. All right. So reactant minus product, negative exo, positive endo. All right. Now let's calculate for reactants. What is the energy given for hydrogen bonded to hydrogen? It is 436. So we'll do 436 times 2 plus oxygen double bond oxygen is 498. So the reactant's energy is coming out to be 1370 kilojoules per mole. All right. The product, now, a lot of students end up making mistakes in the product. Just think about it. You have two molecules of H2O. Let's first of all count the number of bonds in one molecule. There is one bond and there is another bond. So there are two bonds of OH in one molecule of H2O. Now this is times 2. So there should be 4 times oxygen hydrogen bonds. Alright. So 4 times 464, which is 1856. Now you simply do reactant minus product, which is 1370 minus 1856. So negative 486 is the answer. Answer should be C. Alright. Now question number 12. Which process involves a chemical change? See, chemical change is the one where a new product is formed, or a gas is formed, or color change is there. All right. So now, in option A, we know that when you add sodium to water, it forms NaOH with hydrogen gas. So we clearly know this is a chemical change. So let's consider A. Boiling water, this is just a physical state change. No. Dissolving sodium chloride in water, this is a dissolution process where you're just making it aqueous. You're converting it from, let's say, solid to aqueous. So again, this is just a state change? No. Producing water from aqueous sodium chloride, this is also not a state change. This can be done using distillation. They have different boiling points, so it using physical properties. So answer should be A. Now, next question, 13, B part. 13th question. An experiment is carried out to find the rate of reaction between HCl and zinc. The results of the experiment are shown. What is the label on y-axis? See, first of all, you need to understand whatever is present on y, it is decreasing in amount, right? Now just think about it. What decreases? When a reaction progresses, the product decreases or the reactant decreases? According to common sense, we can say that the reactant decreases, right? When reactant decreases, only then the product increases. Very basic logic. So those who are picking that ZH2 will be there and ZnCl2 will be there, but you're wrong, because product increases, not decreases. Now, out of B and C, a lot of students will make the mistake and they will pick C. See, read the term properly here. Mass of zinc reacted. Just think about it. When the reaction is going on, the amount of reactant consumed, the amount of reactant reacted increases, right? Initially, let's say you had 100 grams of zinc, then the reaction started. Now the reaction is going on. This mass is reacting more, right? When the reaction goes on, you're forming product. This mass will start to react more and more. Is that right? So mass of zinc reacted will increase. The concentration of HCl will keep on decreasing because it is getting used up. All right. So the answer should be hydrogen peroxide decomposes to form water and oxygen. All right. One equation is given. Now they're also mentioning you're adding a catalyst. All right. The reaction is investigated in 4 experiments. So what they're doing here is they're using different conditions, different volume, different concentration, different temperature, and then all reactions go to completion and all measurements of gas volumes are at room temperature. Which statement is correct? All right. So let's first of all do one thing. Let's figure out the moles here first of all. So we know that moles into volume is concentration, because concentration is equals to moles over volume. 1 minute, something wrong I have written here. Concentration is moles over volume. So moles are concentration into volume. This is correct. Now, if you look at A, the experiment 1, the volume is 12.5 divided by 1000 into the concentration is 1. So this will be the moles. And in all the other 3 experiments, 2, 3 and 4, I can tell you the numerical value. You can solve it out later. But the moles are same for 2, 3 and 4. Why? Because this is 12.5. So 12.5 by 1000 into the concentration 2. Then 25 by 1000 into the concentration 1 and 25 by 1000 into the concentration 1. I think you're getting it. The moles are same for all the 3 experiments, 2, 3 and 4, different for A. In A, the moles are clearly less. So you can say less moles. If moles are less, then the volume produced will be less as well. Alright, because it all depends upon stoichiometric ratios. If the moles is X here, only then, now you check the ratio between H2O2 and oxygen. The ratio is 2:1. So this will give you X by 2 moles. Now in reality, if you already have lesser moles here, this will also give you lesser moles. Alright, now let's look at statement A. Experiment 1 produces less gas than experiment 4. This is true. But at the same rate, are the conditions same? No, the temperature is different. So the rate of reaction should be different. Incorrect. Experiment 2 produces more gas than experiment 1. This is correct because experiment 2 has greater number of moles. Now, but at the same rate, are the conditions same? 40, 25? No. Experiment 2 and experiment 4 each produce the same volume of gas because the number of moles are same, number of moles of H2O2 used are same, but at different rates. Now let's look at the conditions. In experiment 2 and 4, the temperature is 40 degrees Celsius and they are using it along with the catalyst. So this looks wrong for now, but at different rates. But you also need to look at the concentration. Concentration also affects rate of reaction. Now, if you check the concentration here, it is 2 and it is 1. It is 2 and it is 1. So rate should be different. So statement C is correct. Now in statement D, experiment 3 and 4 produce same volume of gas. This is true. But at the same rate. Now this is problematic here because concentration is same, correct? Temperature is also same, correct? But the catalyst in experiment 3 they are not using the catalyst. In 4 they are. So it should be different. That is why D wrong. All right? Now question number 15, you have to remember the conditions for contact process. Vanadium 5 oxide is used. Temperature is same in contact and Haber process. The pressure is 2 atm and we know that 2 atm is 2 into 10 to the power 5 pascals, right? Which is 200 kilopascals. So that is why 200 kilopascals is written here. All right, do not make the mistake that I remember 2 atm. Let's say they will give you 2 atm in some of the options. Do not pick that one. 2 atm it is there, but 1 atm, 1 atmosphere contains 10 to the power 5 pascals. So answer should be C. Now, which equation shows reduction of copper? By reduction of copper, you just need to check where copper is losing oxygen. If copper is losing oxygen, that is reduction of copper. So in option A, clearly we can see copper has oxygen here, but on the product side, no oxygen. This is reduction. Right? State changes are not reduction or oxidation. You can consider option B. See, this is copper sulfide. Copper has X, so sulfide has -2 charge. X is +2 here. In copper oxide as well, it is a +2 only. So there is no change. Answer should be A. All right. Now, which statement about acids is correct? A weak acid partially dissociates in aqueous solutions. This is correct. An acid accepts protons? No, it donates protons. Ethanoic acid acts as a strong acid? No. Carboxylic acids are weak acids. Hydrochloric acid is a strong acid? This is correct. It ionizes? This is correct. In water? This is correct. To form H negative ions? Incorrect. It is H plus ions. Statement with D is also wrong. Solid? This is telling you you have to read everything properly. Do not hurry any question. Now this just one word, in place of H plus they have written H negative. This is why the statement is wrong. Alright, so read everything carefully. Now, copper sulfate is formed by reacting excess solid copper carbonate with its dilute sulfuric acid. Which processes are part of preparation of solid copper sulfate? So we are preparing a soluble salt here. This is the excess method. Alright, now crystallization is done in the soluble salts. That is true. Then filtration is also done because you're using excess solid copper carbonate. See, the remaining excess needs to be filtered out, right? So 1 and 3, A should be the answer. Alright, now question number 19. Which type of reaction is represented by equation shown? Do not make the mistake thinking that, oh, ions are present here, so this should be redox reaction. It's not. It's not a redox reaction. I'll tell you why. Look at the oxidation states everywhere, they're ultimately the same. Lead is 2 plus here. Here its oxidation state will also be 2 plus. You can check, find it out later. Na is +1, Na is +1. NO3 is -1, NO3 is -1. Iodide ion is -1. Here it will also be -1 only. So it's not a redox reaction. Then what is it? Look at here. This is a solid being formed. So it's a precipitation reaction. I think you have done this already. Then when you write the net ionic equation, the common ions get cancelled out. This ion will get cancelled out, Na will get cancelled out, and you will have remaining is Pb2 plus aqueous plus 2I negative aqueous giving Pbi2 solid. So this is your precipitation reaction. D. Which compound is likely to be colored? From this we can tell it must be a transition metal. So which compound contains a transition metal? A. Manganese is a transition metal. Rest all are non-metals or metals. Which statement about metal zinc is correct? It is extracted from the ore bauxite. No, this is for aluminium. It is used to galvanize steel. This is correct. It is used to make alloy brass. Correct. It reacts with dilute hydrochloric acid to produce hydrogen gas. Zinc plus HCl gives you ZnCl2 plus H2. Is this correct? It is correct. So statement 2, 3 and 4, option C. Now, electronic configuration of 4 elements are shown. Which elements are unreactive monatomic gases? So for unreactive, we need to check which one have fully filled valence electron. Fully filled valence electron. First of all, element S. This is the configuration of neon. You can check in the periodic table. Neon has atomic number 10. So the configuration is already 2, 8. Then we need to look for helium. And you know that helium has a configuration of 2 only. So answer should be P and S. Alright, do not make the mistake of picking Q because it appears uniform. There is no concept here. It should be 2, 8, then you can call it unreactive. It is not 2, 8, it is 2, 2, which is reactive. So P and S should be the answer, which is option number B. Option B. Now, which row compares the strength of alloys with pure metals and explains the difference in strength? We clearly know that in alloys, different sizes of atoms are there, so it makes it difficult to slide over, right? And the strength of an alloy compared to a pure metal. See, what is the benefit of making an alloy? An alloy. We want it to be stronger. So option A, option B out. Option C, option D, we will consider. Now, what is the explanation? Larger atoms slide more easily. If it was sliding more easily, then what is the benefit of making hard alloys? It won't be hard, it will be soft. Larger atoms make it harder for layers to slide over. This is why the strength increases. So answer should be D. Now, zinc oxide reacts with carbon to produce zinc. Now just think about it. Zinc oxide reacts with carbon to produce zinc. Means zinc is getting reduced here. Zinc is losing oxygen, right? Loss of oxygen is reduction. So now you need to look at the equation which is balanced only. All the equations have nearly the same. One contains carbon monoxide, the other contains carbon dioxide. So you just need to look at the equation which is balanced. So two zinc atoms here, two zinc atoms here, one carbon, one carbon, one oxygen, but here you have two oxygens. Incorrect. Two zinc, two oxygen, two zinc, four oxygen. Incorrect. One zinc, one carbon, one oxygen, one oxygen. C is correct. Alright, now when a piece of aluminium foil is added to dilute HCl, no effervescence is seen. Which statement explains why no effervescence is seen? They're simply asking you, when you add a piece of aluminium foil into dilute hydrochloric acid, we expect it to react, but it does not. Why? Because aluminium has a protective layer of aluminium oxide on it. So aluminium has a surface layer of aluminum oxide which makes it unreactive. This is why aluminum foil are used in packing food in containers, because it is unreactive, because there is a layer of aluminum oxide already there. All right. Now, question number 26. Iron nails are stored in airtight container. See, the nails begin to rust after a few days. For rusting, we simply need water and we need oxygen, right? How can the rusting of the nails be prevented? See, water is clearly not present here and air is present here. We need water, and water can be in the form of moisture as well. From air, you can also get a little bit water. Leave the lid off, replace the air with argon. B should be correct because argon is unreactive, but air is reactive. Air will react with the iron nails. Right? So answer should be B. Now, question number 27. Four substances present in the blast furnace during iron extraction are listed. Calcium carbonate, carbon dioxide, carbon monoxide, iron 3 oxide. Which substances are both a reactant and product during this setup? Alright, so we know that the first reaction is carbon plus oxygen giving CO2. So CO2 is a product here, but in the second equation, carbon reacts with CO2 to form carbon monoxide. So here carbon dioxide is the reactant as well. So we know that one answer should be carbon dioxide. And in the third equation of iron extraction, Fe2O3 reacts with carbon monoxide to form Fe and CO2, right? It's not balanced, but you get the idea. So here again, CO, carbon monoxide, is a reactant now. So both carbon dioxide and carbon monoxide behave as reactant as well as products. So answer should be 2 and 3, which is C. Now, question number 28. Aluminium is extracted from purified bauxite by electrolysis. Which row shows the ionic half equations for the reaction at each electrode? Anode, cathode. Now, first of all, anode is the positive electron. So it should be attracting negative ions. So A and B is already incorrect, right? And cathode is the negative electrode. It should be attracting positive ions. So from this sense as well, these two are incorrect. Now we have to differentiate between option C and D. So for aluminium oxide, aluminium Al2O3, we know that Al3 plus gains 3 electrons and it forms Al, right? And this will happen at the cathode because cathode is negative charge. Now, is this equation correct? I don't think so. Is this equation correct? This is correct. Let's also check for oxygen. O2 negative will form O2, but 4 electrons will be there as well. And here you will have to put a 2. Why? See, single oxygen has excess of 2 electrons, right? Two oxygen, two oxide ions. Single oxide ion has negative 2. So two oxide ions will have negative 4 excess electrons, right? So in order to balance it out, you add 4 electrons there. So that is why option D is correct. Now, which test is used to show that sample of water is pure? Evaporate the water to see if any solids remain? No. Heat the water to check its boiling point. This is correct. The boiling point of a sample varies if it is impure. All right. So B should be the answer. Test with anhydrous cobalt chloride. See, the test with cobalt chloride and copper sulfate, these are the tests to check whether water is present or not. Now, it can be present in pure or impure form. That doesn't matter. They will just show you that whether water is present or not. This test is regarding purity. So for that, the best test is check the boiling point. Due to impurities, it varies. Alright, now catalytic converters in car exhaust change polluting gases into non-polluting gases. Alright, which statement about oxides of nitrogen and car engines are correct? The nitrogen in oxides of nitrogen comes from compounds in the gasoline. This is incorrect because the nitrogen from in oxides of nitrogen is taken from the atmospheric air nearby. So statement 1 is incorrect. The oxygen in oxides of nitrogen comes from the air in the car engine. This is correct. And catalytic converter converts oxides of nitrogen into nitrogen. This is correct. Whatever nitrogen oxide it is, NO or NO2, catalytic converter converts it into unreactive N2. So 3 is also correct. So answer should be 2 and 3. Now, the structures of two molecules are shown. Which row describes X and Y? See, if they were structural isomers, the number of carbon and number of total atoms will be same, right? So you count carbon atoms here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So these are not structural isomers first of all because the number of carbon atoms are not even same. Now, do they belong to the same homologous series? See, here we can see a double bond, so it's an alkene, and no other oxygen, any other atom is present, only carbon, hydrogen, and double bond is present. And here also, only carbon, hydrogen atoms are present with some double bond, one with double bond. So, yes, they do belong to the same homologous series, but they are not structural isomers. Wait. A little bit correction. We have to pick whether they are structural isomers or not. So, they are not. So C and D should be correct. A and B is correct because structural isomers they are not. Do they belong to the same homologous series? Yes. So the answer should be B. All these two are not isomers because the number of carbon hydrogen atoms are not same. So that is why no. And do they belong to the same homologous series? Yes, because double bond and double bond, nothing else is present. So answer should be B. Now, next question. What is the structure of butanoic acid? It's very simple. Bute stands for 4 carbons. Does it contain 4 carbons? No. Does this contain 4 carbons? Yes. Oic acid is double bond O, then OH. C double bond O, OH. This representation should be there. Is it like that? No. Does it contain 4 carbon? No. This is the structure of propanoic acid. Now, if you look at this, 1, 2, 3, 4, bute is there. Yes. Double bond O, then OH is present. Yes. This is the butanoic acid. When a mixture of methane and chlorine is exposed to ultraviolet light, a reaction takes place. Which statement about this is correct? It is an addition reaction. No, addition reaction takes place in alkenes. This is an alkane. The ultraviolet light provides the activation energy. This is correct. An equation for the reaction is CH2, Cl2, H2. No, the first equation will be CH4 plus Cl2 giving CH3Cl plus H2. So this is wrong. CH3Cl is made in the reaction. This is what I have written here. So the answer should be 2 and 4, which is D. Esters are formed when carboxylic acid reacts with an alcohol. All right. What is the catalyst for this reaction? We know that acid catalyst is used here, and which is sulfuric acid. Potassium magnet is used for oxidation, not for esterification. Now, the diagram shows part of a polymer. Which diagram shows the monomer from which this polymer is made? See, first of all, we have to pick out the monomer, and you can say the carbon hydrogens are repeating here. So you can pick any pair like this. So if they were asking you the repeating unit, your answer should have been this. Repeating part of polymer, if they were asking you, your answer should have been this. But they're asking you even simpler, which is monomer. So these bonds that you have drawn, you have to remove them and put a double bond in between. So the answer should be C. Now, nylon and PET are polymers. Which statements about these polymers are correct? They are both condensation polymers. This is correct. This is alcohol and this is alcohol. So they're talking about diol. A molecule with two alcohol is called as diol. Could be a monomer for both polymers. This is incorrect because, as I have pasted the photos here as well, for a polyester, dicarboxylic and dialcohol is required. So here alcohol is required. That is correct. But for nylon, which is a polyamide, dicarboxylic and diamine is required. So here diol is not required. So 2 is incorrect. The complete combustion of both the polymers gives two products only. This is not true because if a compound contains carbon, hydrogen, oxygen only, then the combustion will give you CO2, H2O. But in case of polyamide, nitrogen is also present. So some nitrogen gas will also be released. Alright. So statement 3 is also incorrect. Your answer should be C only. Now, ethane is used as a fuel. Which equation shows the complete combustion of ethane? So ethane is C2H6 plus O2 giving CO2 plus H2, right? So first of all, this is not ethane, this is not ethane, cancel, cancel. So here they will put a 2, all right. 7 oxygen here means total 14 oxygens they have put here, and 4 times 2, 8 here, plus 6, 14. Oxygen is balanced, all right. So the answer appears to be A because it's a balanced equation. Here they have written carbon monoxide, so you did not even have to balance it. They've written carbon monoxide, which is formed under incomplete combustion. In complete combustion, carbon dioxide is formed. All right. So the answer should be A only. Now, question 38 looks like a complicated question. A lot of values is given, but it is very simple. See, the painkiller paracetamol is synthesized from 4-aminophenol. Chromatography is done on an impure sample of paracetamol. The results are shown. The diagram is not drawn to scale. So there is paracetamol. It contains pure paracetamol as well as some impurity. Okay. So here they are showing you that what a pure paracetamol sample will look like. The pure paracetamol sample will only travel this distance. But now in the impure sample that you have, little paracetamol is there, and little impurity is also there. All right. So we can simply say that the impurity will have a different distance. So this is the original pure paracetamol sample. The sample of paracetamol is contaminated with 4-aminophenol only. So there is only one impurity. What is the RF value of 4-aminophenol? So RF value we find out by distance traveled by the impurity by the solvent. Now, if you check what is the distance traveled by the solvent, the distance traveled by the solvent is 3.5. And what is the distance traveled by the impurity? Is it 1.7 or is it 2.6? Those saying 1.7, it is incorrect because 1.7 is what pure paracetamol is traveling, right? So impurity is traveling way higher, which is 2.6. So when you divide 2.6 with 3.5, let me check the calculator once. 2.6 divided by 3.5. So the answer is coming out to be 0.74. So answer should be C. Alright. Now, the two equations, the equation for the reaction of aqueous calcium nitrate and aqueous sodium hydroxide is shown. Which process is used to remove calcium hydroxide from the mixture? See, calcium hydroxide is a precipitate here. It's a solid here. So you can simply do filtration. Very simple. Everything is in aqueous form here, but calcium hydroxide is a solid here. So filtration will work. Now, question number 40. This is a factual question. You must have done the practical in school, but for this paper 2, you have to remember the observations and which ion shows which color. So I've pasted a few screenshots from the paper 6 salt analysis sheet. The results of two tests on aqueous compound X are given: warm with aluminium foil and aqueous sodium hydroxide. So when you look onto your paper 6 salt analysis sheet, it is clearly written here: add aqueous sodium hydroxide, then add aluminium foil, warm carefully. See, this and this is exactly the same. And result is ammonia produced. Ammonia produced. So what is it telling you? It is telling you that nitrate ion must be present. So if nitrate ion is present, C and D is already out of options, right? Now, aqueous sodium hydroxide and it shows brown precipitate. So in the positive ions, that is the cations, when you add aqueous sodium hydroxide, so where is the brown precipitate? Brown precipitate. So the answer should be iron 3 nitrate. Iron 3 nitrate. So the answer should be A. Alright, now we're done with this paper. In case of any doubts, let me know in the comment section. I'll be more than happy to help you.